The formal definition of the derivative is f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. So in other words, what we want to do is when we find the derivative, instead of finding a singular value, we want to come up with the function. So what you're used to doing, and what we did a little bit the other day, was we said, well, suppose that f of x is equal to the square root of x. And you want to find the slope at a is equal to 9. We had that problem in our little game yesterday, didn't we? Which you guys did a great job with, by the way. Good job. And you came up with f prime of a was equal to 1 over 6, right? It turns out that this thing right there, that it has a derivative. It has a derivative of a function. In fact, the derivative at f, and I'm going to teach you how to do this, the derivative is 1 over 2 roots of x. That's the derivative of this function. Watch what happens if you plug in 9. What's the square root of 9? Times 2. So that means instead of doing the derivative at every single point, you can do the derivative once and plug in whatever points you want. It would tell you the slope at any time, any place. It's a beautiful thing. So let's do this piece right here. You tell me first, what does the graph of root of 2 minus x look like? Yeah, so I see people doing that, okay? It's shifted to the right 2 units, and then because the x is negative on the inside, it's a horizontal flip. Yeah, so it's going to go like that. Everybody see that? Describe for me that derivative. It's always negative. Everybody agree that derivative is always negative? So we should come up with a function that when we graph it sits below the x-axis all the time. Let's find the derivative. F prime of x is equal to the limit as h approaches 0 of, let's see what we do. We write the function, but instead of putting an x, we put a x plus h. So I have the square root of 2 minus x plus h. Remember to distribute the negative all the way through. So I wrote parentheses there. It says minus the function. What is the function? Square root of x. I'm sorry. Square root of 2 minus x. All over h. Anybody, what would I get if I plugged in 0 over 0? Oh, I do that all the time. Anybody, what would I get if I plugged in 0 for h? I get 0 over 0. Oh, no. So we got to make sure we open up this h so we could try to get them to cancel. Anybody have thoughts about how I could get rid of these square roots? Conjugate. Yep, let's multiply by the conjugate. Everybody okay with my setup so far? All right. We multiply these two. What do you get? So we're going to FOIL these two things out. So we'll multiply the first two terms. And the square root's going to go away, right? Okay, 2 minus x minus h. Good. What's going to happen in the middles? They cancel. And if I multiply these together, minus 2 plus x, because you got to distribute the negative, right? Good. So minus 2 plus x. In the bottom, I have h times the square root of 2 minus x plus h plus the square root of 2 minus x. Is everybody okay with the bottom? Good. What do you notice? Everything that doesn't have an h goes away, so the 2's go away, the x's go away. Is the h positive or negative? So when it divides off, we'll be left with negative 1. So I have the limit as h goes to 0 of negative 1 over, in the bottom you have the root of 2 minus the quantity x plus h plus the root of 2 minus x. Can I now plug in 0 for h? So if I plug in 0 for h, I get negative 1 over, if I plug in 0 for h here, what's this thing going to be? Root of 2 minus x? What's the root of 2 minus x plus the root of 2 minus x? 2 times the root of 2 minus x. If we were to multiply them, the square roots would go away. If we add them, we double it. Right? Everybody see that? Good. So, take out your calculator if you'd like to. Take a look at this. I'm going to type it in, just see what I get. So we have the square root of 2 minus x. And then as we look at y sub 2, I'll type in negative 1. Whoop, that's a subtraction sign. Divided by, parentheses, I put in 2 roots of 2 minus x. And the first one will be, we'll try that again a little bit. Oh, that's enough. I guess I'll zoom standard. We'll just zoom standard. We see it again. So that's what we thought the function looked like, right? Look at the derivative. It always sits below the x-axis, right? And you notice when the domain runs out for the original function, the domain also runs out for the derivative, correct? A nice way to be able to verify your answers. But this is the derivative. This is f prime of x. Tomorrow's a work day on your assignment, by the way. Okay, so we want to get the instruction today. You have all day tomorrow to work on the worksheet. All right, let's try the next one. What's different about this one? Yeah, it's definitely a fraction. Tell me anything about its derivative. Is this differentiable everywhere? What is the spot where you can't take the derivative? At 3. So we should see when we come up with the derivative that you still can't plug in a value of 3, correct? Here we go. F prime of x is equal to the limit as h goes to 0 of, again, we're using this definition right here. What do we plug in? We plug in x plus h wherever we see an x. So I have x plus h over x plus h minus 3. Minus what? X over x minus 3. All over h. If I plugged in 0 for h right now, what would I get? 0 over 0. So I have to try to remove the h. As Colin said, this is a complex fraction. What do I have to do when I have the complex fraction? Common denominators. So multiply top and bottom here by x minus 3. And multiply top and bottom there by I get the limit as h goes to 0 of, multiply out x minus 3 times x plus h. What do you get? X squared plus xh minus 3x minus 3h. What's next? Minus x squared minus xh plus 3 over, I'm not going to multiply the denominator out. Usually it's 3x. Usually it's nice to leave the denominator in factored form, x minus 3 times x plus h minus 3. It's nice to leave it in factored form. Usually works out quite nicely. All over what? H. What do you notice? X squares are gone. XH's are gone. Negative 3x and positive 3x are gone. Now I can multiply by the, and when I multiply by the reciprocal, do I just get an h down in the denominator there? What's going to happen with that h? Cancels. What am I left with in the top? Limit as h goes to 0 of negative 3 over x minus 3 times x plus h minus 3. Can I now plug in the 0? So if you notice, there's not a plus sign here, is there? This is multiplying. So you get x minus 3 times x minus 3. So we get negative 3 over x minus 3 quantity squared. That's your derivative. That is f prime of x. What value can you not plug in? 3. Does that match with what we had up above? Yes, it does. Stays true. Our last example. Okay, on your own, please try to write the first expression. Don't try to do any of the algebra yet. Just try to write the first expression. See if you can do that. Okay, is that what you got? Excellent. We have two problems here. What are the two problems? Yeah, you got the multiple square root piece, and you also have a complex fraction, right? So when you get with this type of situation, please deal with the complex fraction first. So we're going to have to deal with complex fraction, and as you anticipate, we'll have to multiply by a conjugate, correct? Do not deal with the conjugate situation first. Deal with complex fraction first. So I multiply top and bottom here by what? Good. Multiply top and bottom here by? And I get 2 roots of x minus 2 roots of x plus h over root of x times the root of x plus h all over h. I now have a fraction over a fraction, so what can I do? Multiply by the reciprocal. And when you do, can everybody see that when you do, you're just going to get an h that joins in the denominator? So I'm just going to put this h right out front there. I'll do it again. So if I multiply by the reciprocal, that'll be a 1 over h. Notice how the h just joins in the denominator. Took care of that complex fraction pretty quick. Now we multiply by the conjugate. And the conjugate is 2 roots of x plus 2 roots of x plus h. In the denominator, 2 roots of x plus 2 roots of x plus h. You tell me, what do I get in the top? 4x, good. Is it plus 4h or minus 4h? Minus 4h. Isn't that nice? I mean, it really is nice that it works out not like that. You just see how everything cancels. In the denominator, we have a huge mess, don't we? I mean, it's a ridiculous mess. So we're just going to have to be really careful. Fortunately, you were excellent at algebra. For people who are not excellent at algebra, we would struggle bus here. So ride the struggle bus. That's a new term I've heard. Never heard that before. Heard it the other day. Going to ride the struggle bus on this denominator. Is it like, so if I start saying it, does it ruin it then?
No,
like you then?
It's like, how about struggle bus? Everybody's struggling.
Okay, I don't want to make things uncool for you guys. I know I don't exude coolness. I know you guys are. Like if I think of cool, I think of like Carter Miller. It's like this just comes to mind. I don't want to ruin your image, dude. Yeah, exactly. Love your shirt. All right. 4x's cancel. The h cancels, leaving you with what in the numerator? So the limit as h goes to 0 of negative 4 over root of x times root of x plus h, parentheses 2 roots of x plus 2 roots of x plus h. Oh, what can I finally do? Plug in 0 for h. If you were wondering how to do that sometimes it's nice as you plug in 0 for h, you just kind of scratch them out because they just go away, right? So what is the square root of x times the square root of x? X. What is 2 roots of x plus 2 roots of x? 4 roots of x.
Wait, if it's 2 roots of x, is 4x, or you still have to keep the...
You still have to keep square root. Yep.
Okay.
And how does that simplify? Nice job.
Okay, that is not too much.
No, not too much. You guys are smart. Way to go.